Welcome to this section on corrective measures. In the previous sections, we trained the model on the tiny image dataset and we got some results. The model performed very well in the training dataset, whereas in the validation dataset, it performed very poorly. This phenomenon is known as overfitting. And as we could see right here, this model, which normally should be stable, isn't stable because we have overfitting. Now, let's seek ways to resolve this. So, one of the most popular ways of resolving this problem of overfitting is through data augmentation. So, when given a data set, like suppose we are having this one image of the bird, we could flip it, say this, this, and this. So instead of working with just this one image, we work with 4 of this. And if we repeat this process all through the data set, a data set of 100,000 images will become 400,000 images. And this technique of just flipping the original image to have this image, this one, and this is just one out of many other data augmentation strategies. And sometimes, depending on the kind of problem you have at hand, you may decide to prioritize some data augmentation technique with respect to others. Generally, when carrying out experiments, that's when training, performing, that's carrying out performance measurement and validating, what you could do is you could train a model based on a certain data augmentation strategy. That is, suppose we have strategy 1, which entails rotating this original image into these 3 other images. Then we measure its performance to see how good this data augmentation strategy is. And then we could use another data augmentation strategy, which is maybe of just cropping up some parts of this image. So we could crop some sections, or we could do a center crop. So we could crop each image at the center and produce other new images. Then again, we measure its performance to see how well cropping at the center or cropping any other portion of the image helps in reducing overfitting. Then after testing the 2 data augmentation strategies, if say one of these strategies helps in increasing or reducing overfitting, then we could adopt that strategy. If both actually help reduce overfitting, we could simply adopt both strategies. Generally, in problems like this, we could adopt many other strategies. So we could crop, we could flip, we could rotate, we could do many other transformations on this image or on one of the images in the data set, such that we could have much more data to train on and hence reduce overfitting. The next and very logical thing to do when trying to reduce overfitting is collecting more data. And it's advisable to collect data which is representative of the test set, or where exactly we are going to apply our model or use this model. And also it's advisable to collect data which is diverse, that is data from different sources, from under different conditions. Say for example, if you want to collect data of birds, you could collect them in different locations, under different weather conditions, under different lighting conditions, such that if this model wants to be used under any of these conditions, it will actually work well, since it has already been trained on data which is gotten from different types of conditions. So let's take a simple example. Suppose you want to train a model which will be used on the streets to locate the presence of a dog or not. And then you go ahead and collect this. Suppose we have this dog image and this other image and many other images, maybe free on the internet. So you just go ahead and collect those images from some website and then you train your model on it, you will find that if you are to apply it in this kind of condition, sometimes your model may fail. And this is simply because in real life, we don't have images of the dog with this kind of red background, because this isn't very natural to have this kind of red background. Also, you may not have images of a dog besides this kind of door with this floor. So it's going to be advisable to collect as much data as possible which is representative of the kind of environment you are, like this one. So you could collect as much data outdoors instead of getting just data of dogs which are indoors, because the model may fail to perform well on new data, hence making it very useless. So suppose you train your model on this kind of data and you have 99.9% accuracy, and then you're very sure that when you deploy this model in a real world problem or in real life, you're going to have similar kind of accuracy. But then months later, you are told by those using the model that many times the model detects objects which are not dogs as dogs. And this is simply because right from the beginning, the kind of data you have been using to train the model wasn't representative enough of the conditions under which the model was to actually do inference. Another case is when we want to produce a general purpose classifier for a dog, for example. In that case, it's important to collect as much diverse data as possible. So you just collect data from all sorts of sources and under as many conditions as possible, so that your model would hardly see a dog doing inference under conditions it hasn't seen before. Then the next way to reduce overfitting is by including dropout. As we shall see, many practitioners use dropout in order to reduce the effect of overfitting. And then the next technique used is regularization, more specifically the L2 regularization. And then we have L is stopping, which actually doesn't reduce the effect of overfitting, but just permits us to record the model state before it started to overfit, such that the model we're using for testing and inference is one which wasn't already overfitting on the training set. Then the next method is by working with smaller networks. So very deep neural networks tend to cause overfitting since we're working with so many parameters. So in a kind of problem, or if you have a problem where you have too many parameters and the data set is very small, you may tend to overfit on that training data set. So it's advisable to increase the amount of data we're working with or to reduce the network's size. And then finally, by selecting the right hyperparameters, you can actually reduce overfitting. We now get to look at existing popular convolutional neural network based models. The first we shall work with is the VGG network.